Hey everybody, this is Larry. This is me going with Q2 of the weekly contest 429, maximum number of distinct elements after operations. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. So this one I actually did very quickly, as you saw, in about 2 minutes, and I actually took some time to make sure that it worked. But the idea here is just greedy. So you know that you're given a range from a number from negative k to k, and really the way that I want to think about it is just by visualization. I think a lot of these problems, if you have a good visualization in your mind, it just makes it easier to, well, just to think about it, right? And here, instead of this nums, then now I kind of have this number line, right, of all these, actually, just like a one-axis thing. I'm drawing on my touchpad, so it's going to be terrible. I'm not at home with my drawing thing. But yeah, let's change the color real quick. And then, yeah, it'll just be, so then they all have the same length, right? Just to be clear. So then you have kind of like this, you have, like this, say, they're the same length, but I'm just drawing them not, right? So, and I think the key thing to note is that in the problem, it said that you can do operation on each element at most once. So that is another way of saying, honestly, that the order doesn't matter. And also that you could do it because every element can be done once or not. Right, so that's also another way of saying that the order doesn't matter. At least for this, well, order doesn't matter for the operation, but also because in this particular problem, it's about distinct numbers, right? So the order really doesn't matter in the original thing. But in any case, yeah. And then now that I see something like this, and I'm a little bit drawing with the fingers are kind of tough, so I'm not going to do more. But yeah, but the way that I think about it is just a sweep line algorithm, right? So I sweep from left to right, and yeah, and then now it just greedily slots everything in, right? So this is the first number that I sweep by. So then now I go, okay, well, let's just take it, and then let's say there are a lot of dupes, right? I think that's the only thing that will make it a little bit tricky. Let's say these are all dupes. So I draw slow drawing. Slowing drawing, what I don't even know how English more. Anyway, and then the next number, well, you know that this is eliminated, so you have to force to the next number, and so forth, dot. And then the only other case is if that, and I didn't draw that one actually, one more case is that you have something like this, and the last biggest number is here, then now you have to jump all the way to here, right? So that's basically the idea behind my code, but the visualization is what made it work for me, right? And this is the code. I actually didn't even use this. I was like, maybe I could do this to kind of save it in a slow, lazy way. But in any case, yeah. So here we take the biggest number, or sorry, the bigger number of the previous biggest number plus one, because the invariant is also that as you do the sweep line, everything left of the biggest is either taken or cannot be used anyway, right? So here, x minus k is going to be the smallest number that the range that here you can go to. Also, I missed saying this, but of course you sort. I built it up with a lot of saying that order doesn't matter, so first you sort. Yeah, and then now there are only two cases, like I said. If the new x is within bound, which means for x, then we add it to the set. Oh, I guess I did use set, but I don't need it because we don't use it for any. Oh, no, we do. Okay, my fault. My apologies. I guess I did use it for this, but actually you don't even need to, right? Because this is just, I think yeah, because here we do it. So I think I just kind of did it for, I don't know. I didn't want to think about the reasons. And this is contest code, right? So, oops, what am I doing? So I'm trying to go for like the thing that I don't have to prove, and that's basically what I have. But let's give it a quick submit to make sure that this is still working. Yep. Yeah, same idea though. If it's within bounds, that means that we can use it for x, so then we just increment count. We make biggest nx, and then that's it, right? We throw away everything that's smaller than that, including itself. Yeah, it's going to be dominated by n log n num sort, and that's it. That's what I have for this one, right? That's the complexity. And then O of one space after this. But of course, sorting is O of n space, depending on who you ask and whatever. Maybe you could say it's in place, but then you're changing the input. So whatever. Anyway, my point is that this is it. Yeah. I think one common question that you might ask is that, honestly, I got it in 2 minutes. How did Larry do it in 2 minutes? How did he get it so fast? And hopefully that doesn't sound like a humble brag, but that is a common question that I get sometimes. I would not get it on Q3, Q4 today, but today probably Q2. And the answer is honestly just a lot of practice. I mean, yeah, okay, sorry, it's a cheesy answer, but I did recognize this prompt as one is the visualization, but I also thought of it as almost like a variation of the max, minimal exclusion. So meaning the smallest number that's not in a set, and that so the code kind of also built similar to that as well. So I was thinking through that and then build it out and then just type it out pretty quickly as a result. So you know, practice new things, right? So yeah, that's all I have for this one. Let me know what you think, and you could watch me solve it live during the contest next. Yucky, honestly, but it should be okay. Unless I misunderstood it, which is always capable, especially these days. I feel like I'm misreading everything. Nums and integer k. Each element at most once, add an integer, return a maximum after performing the performance. Okay. Whatever, too lazy to manage it. Okay, so then now x minus k Is this right? I feel like this is roughly right, but it's easy to mess up. YOLO. Okay. I thought so, but I wasn't sure, honestly. Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one, this problem, this explanation, everything in between. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye-bye.